assignments, doubts, exams. We have got you back. EduPlanner make every chapter easy to understand. Stay tuned, learn more, grow with us.
This problem, we're given information about a spring balance that can read the mass of objects from 0 to 15 kilograms, and it stretches to 12 centimeters long. A package is suspended to the balance and found that it will oscillate with a frequency of 2 hertz, and we're trying to figure out what is the spring constant and what is the weight of the object. So the first thing for finding our spring constant is we're going to use the equation mg equals kx, where k will give us our spring constant. So we actually want to rearrange this to solve for k. So we'll have k equals mg divided by x. And we have to make some assumptions. We're told that the spring balance reads anywhere from 0 to 15, and that it elongates to 12 centimeters. So we can take that maximum, the 15 kilograms, and that 12 centimeters to plug into this equation here to allow us to figure out what our spring constant is. So when we plug those values in, we get k equals, our mass, we're going to go with 15 kilograms times 9.8 meters per second squared divided by 0.120 meters. So we have to make sure that we do convert our centimeters into meters, so that way our meters for our displacement as well as the meters in our gravity, we need them to be in the same unit. And so when we calculate that out, we get k equals 1,225 newtons per meter. Okay, and so the second part we're asked to figure out is the weight of the object. And so for this, we're going to use the equation of frequency equals omega over 2 pi. Now, we don't know our omega, but we can substitute in omega equals the square root of k over m. We can substitute this in here for our omega, which will then give us the equation frequency equals the square root of k divided by m, all divided by 2 pi. And now we can actually go ahead and solve for the mass of this. We want to rearrange this equation, solving for mass here. And so when we rearrange this all, we're going to end up with mass equals k divided by 4 pi squared f squared. And we can now plug in our values. So we have our k is 1225 newtons per meter divided by 4 pi times our frequency, which is 2.00 hertz squared. And we get that the mass of our package is 7.76 kilograms.